Played with the ideas for a bit, but it didn't look like we quite had the what we
Yeah, I
needed
don't
to
think,
converge.
yeah, we didn't have everything we needed to move forward on it. That's what it looked like.
All right, next time. Ramses wins the award for coolest hair
For real.
by far.
Hello, guys.
Hello.
We got Sanjay here. It's 10 after the hour. It's December 2nd. I think it's about time to kick off the next SecPy. All right, so starting now. All right, welcome everyone. SecPy. We've been going since February of 2017. It's coming up on, what is that, 5 years now? It's been a good run. I picked up the torch January of 2020. So almost in my second year. All hail our glorious founder, Josh Miller. Like I said, he started back in February of 2017 and got a job apparently somewhere on the East Coast in December of 2019. No, yeah, 2019. And I was set to present the next. And he said, "Hey, I'm leaving. Someone else take over." And I was like, "Oh no, I want to present, so I'll do it." Back then, we were doing it in downtown Sacramento on Alhambra Street for any Sacramentans we have here. But it doesn't really matter these days. COVID pushed us onto Zoom, and it's been fun to see how things opened up. We're on chat channels. I'm sorry about that top QR. I'm not in QA. That thing doesn't work anymore. The time was you could invite people to SacTech. Apparently it's now this exclusive crew. But the Discord channel should work. I run that one. That's my company, Brazen Studios. Pardon the leap spelling there. It's not like that on my IRS documents, but I'm on both of those. So if you find your way onto SacTech, there's a SacPy channel. We're pretty active. Sometimes I see people ask questions and sometimes I see answers. I'll always post links to the thing on there, but I'm trying to grow the Discord, so if you can get on there too, I'll be there as well. We also have some social media, SacPy Twitter, there's an underscore there. Subreddit. I don't post the Zoom links there anymore because of Zoom bombing in the past. That was kind of fun in the beginning of COVID. I'll post stuff in the Facebook group. If anyone's still waiting to get into the Facebook group, as always, I'm sorry. I will get to you eventually. I look at that one sometimes. We also have a Facebook page. I mostly just post Facebook page updates into the Facebook group. All right, so if you can, turn on your camera. This is the community and past events. I'm going to give my best possible, like, Brady Bunch view there, if you can. Oh, Dylan, I like your hand there. That's pretty good. Keep that like that. Don't change. Oh, Cezanne's got the hat memo. Oh, man. I need to put my camera on. How about that? That's the whole thing. Wait, how do I turn the camera on? What's going on here? Oh, man. Snafu. Oh, there we go. All right. All right. On 3, 1, 2, 3. Hey, do a few. Yeah, Ramsey's coolest hair, definitely. Okay. All right. So next up, our star of the show today, Sanjay Siddhanti is with us from AKASA. Sanjay's been doing some cool stuff for the Python community since the pandemic got going. He's talked at a number of Python organizations, PyBay, who helps us out with these Zoom meetings. We're on their Zoom account. He's also done some things with PyGotham. I'm assuming that's not the DC universe, that's New York. He's also presented for PyCon in Australia, as well as PyTexas. If I can offer a suggestion to PyTexas, PyTex, put that, SacPy, TextPy. Ooh, there we go. Anyway, he's done some pretty cool stuff in the Python community. He's contributed some things to Python package index. He's also done some really cool stuff in one of my favorite worlds, which is machine learning. He hails from Stanford once upon a time and was in the lab with Andrew Ng, his machine learning lab. I'm sure some of you have heard something about it. Maybe he'll intersperse some of his presentation with some, I don't know, anecdotes of that, but that's pretty cool background. Also, like myself, he's really into Strava. I'll follow you on there. But without further ado, I'd like to hand it over to Sanjay Siddhanti. Also, I'd like to say, if you guys have questions, don't hold them to the end. This is, we're all comfy at home. No one's paying to be here. No one dressed up. Although, except Sazan, he's got the good hair. Oh, wait, no, good hat. Ramsey's got the good hair. Yeah, so he's got this thing about, it sounds like it's an upgrade to robotic process or automation, but he's calling it workflow engines over at a company called AKASA that I understand is doing some really good things with pricing in the medical space, but they're doing it with a strong technological lead. Thanks to Sanjay. So Sanjay, I will give the sharing over to you, if you would.
Sounds good. Thank you. And can you hear me okay, by the way?
We can hear you just fine.
All right. Woody, I'm very impressed. That was the most thorough background check that I think has ever been done on me. You got all the way to Strava and to my GitHub and everything.
Woody does not have a loss for words.
Also, I looked at your website. You did it to yourself, man.
I guess so. Well, thank you all for having me here. I am super grateful for the Python community and happy to be at SacPy for the first time. As Woody mentioned, I hang out in a lot of the Bay Area Python meetups, and I live in San Francisco myself. But I'm excited to be here and get to share some of AKASA's work with all of you and hopefully learn from all of you as well. So I can jump into my talk, but I wanted to say that if people have questions or comments at any point throughout the talk, feel free to interrupt me at any point. I'm definitely interested in making this more of a discussion than a one-way lecture. And can you see my slides?
Yep. APIs and workflows at AKASA.
That's right.
Yes.
Okay. So let's jump into it. First of all, I'm Sanjay. I think I just mentioned that. I really love working on software to help improve the healthcare system. And that's what I've spent my entire career on. I joined AKASA as an early engineer in 2019 when we were about 5 people. And I currently serve as director of engineering. My teams focus on our AI-driven automation platform, which I'll talk about a little bit in this talk, as well as on our data engineering problems. Shameless plug is that AKASA is constantly growing and we are hiring. So if anyone's looking for a new job or knows anybody who is, please let me know. And as Woody mentioned, I studied at Stanford. I did my BS in computer science and master's in biomedical informatics, which is how I got into everything related to healthcare and software. So I can start by telling you a little bit about AKASA. So AKASA is basically reinventing the healthcare space using artificial intelligence and machine learning. Right now, we focus in a vertical called revenue cycle management. And our goal is to take all the paperwork out of dealing with health insurance companies. So a few stats about AKASA. In the 2 years that I've been at the company, we've gone from actually much less than 20 people to I think 150 plus employees now. When we were just getting started in 2019, we were fighting for our first customer. And now our customer base represents over $100 billion in net patient revenue, which I think is 10% of the US healthcare system. And AKASA's software is helping patients in all 50 states, which is really amazing to see. And our models have been trained on actually over 250 million insurance claims and remittances. That's what that should say. So I can talk a little bit about what AKASA does. AKASA uses machine learning to automate tasks that can't be done via APIs. So to take a step back, basically every hospital in America pays massive teams of humans to perform manual repetitive tasks. And those tasks include, I'll give you an example of a simple one. It says, okay, we performed a procedure at the hospital. We submitted a bill to the insurance company, and a month has gone by, or 2 months have gone by, and we didn't get a response. What do? Right now, every hospital in the US pays a team of humans to basically perform this task, which is called claim status. And these humans do it by going into an application called the electronic health record. So this is a desktop application, kind of only runs on Windows, pretty old software. And it's also the backbone of every hospital. It's where they keep track of lab test results, prescriptions, doctor's notes, etc. And they pay these staff members to go into the EHR, grab the relevant information about the claim, such as the patient, the date that the service was performed, how much the bill was for, what procedures were performed, and so on. And then these people open up a web browser, they go to the health insurance company's website, and they type all that information in, click a button, and get the status of that claim back from the health insurance company, and then make a decision based on that. This is a simple type of workflow that I think everyone can understand, but in any hospital, there's actually hundreds of these workflows that are going on at any given time, and hundreds of full-time employees that have to focus on administrative tasks instead of focusing on patient care because of how the system works. And broadly, what AKASA does is we can build an API for any manual task, like the ones I just described, using the graphical user interface of the software system. So we can effectively build APIs to scrape a website, to scrape a desktop application, which is actually a lot harder than websites, because with websites you have access to the DOM and you can use that to cheat and jump around. With desktop applications, all you have is an array of pixels, right? And you have to impose structure on top of that. And but we're able to build bots that can do all sorts of data entry and navigation tasks across any software system that they have access to. So this was actually the workflow I was just telling you about. So we do, I would say, 2 types of automations, which are workflow automation and as well as information extraction. Both of these are backed by machine learning. So first I can talk about workflow automation. This is the one I just told you, where maybe you go into the EHR system, grab the information about a claim, and type it into the health insurance company website. Based on what you get back there, we train a machine learning model to make a decision based on what the health insurance company said, and then go update the state of the claim in the EHR system. This is what we call workflow automation, effectively replicating a workflow that a human could show us how to do. And the way that machine learning backs all this is it helps teach our bots how to navigate around all of these software systems using computer vision, OCR, natural language processing, and those types of technologies. We can also...
That's optical character recognition?
Yes, exactly, sorry. So computer vision...
And a page of text, and then it turns it into, like digitized text?
Exactly. So imagine that...
Question.
I'm sorry?
Yeah. Dylan had a question.
Sure.
Sorry. So basically, you said desktop apps are hard to scrape because you need access to you need to run computer vision on it.
Mm-hmm.
Couldn't you just have access to the back end APIs and the data that's being rendered
Exactly. So
into the front end?
Exactly. So that would be ideal, obviously, if the system exposes an API that gives us direct access. For example, if we can make a call over HTTP and ask for a list of claims within a certain date range. In healthcare, none of the common electronic health record vendors expose APIs for these purposes. And so it's
Oh.
actually a closed system, which is why we don't have direct database access, nor is there any sort of REST API that we can call to get billing data. Increasingly, the industry is moving towards building APIs, but right now and for the next several years, those are all focused on clinical data, like lab test results or prescriptions or diagnoses, but less focused on claims and billing data. Does that make sense?
Couldn't you just run all the traffic through a proxy and capture all the requests
Yeah, so these
and data?
these EHR systems are hosted on customer servers, not on our servers, and so and they are also due to patient privacy laws. All patient health records are encrypted both in transit and at rest, which means wherever they're stored in a database, that's encrypted. Also, anytime they're going over the wire, for example, if you're loading a page in the EHR, all of that data is also encrypted while in rest. And so it's...
What do you use to encrypt it? What, how do you encrypt your data? I mean, like, what, like SS, like, you know what I mean? SHA-256 or something, you know?
Well,
yeah,
to decrypt it, you need the cryptor. So it's like if it's encrypted on the customer's server, the customer server probably builds the key. They don't have access to that key.
exactly.
Gotcha. Cool. Thanks.
Yep. Good question though. Does that answer the question?
Yes, definitely.
Yes.
Yes. And and any system that allows you to get direct access to the backend data, that would be great. But in healthcare, the reason that doesn't happen is actually because of privacy laws, where they require extremely close auditing over who has access to patient health record data. And that's one of the primary purposes that the EHR serves, or that's one of the main pieces of functionality, is that when you're in the front end, anytime you navigate to a patient's record, the EHR is logging a note of who accessed that patient's record, what part of their record was accessed, and at what time. And so the data in healthcare is always very, very locked down to only exist in the EHR or in the front end, or only over a very specific type of API, which is the technologies in healthcare are called HL7 or FHIR, that also accommodate that kind of detailed access logging. Does that make sense?
Yes, definitely.
Okay, cool. So in addition to workflow automation, another type of machine learning task that we do is information extraction. So I'll give you an example. I'm sure you've been to the doctor's office and they've asked for your insurance card. And what you'll see them doing is they put it in a scanner and they basically take a picture of the insurance card and then upload it and attach it to your profile in the EHR system. Now, AKASA wants, maybe we want to go through the EHR system and a customer says, can you help us figure out which of these insurance cards are still relevant, meaning is the insurance still active, and which ones aren't? So we might be able to do a task that combines workflow automation. The workflow part is that we go look up the patient's record, click into their record, open up all the insurance cards. And then we also have machine learning algorithms for example, that know how to run optical character recognition on insurance cards and retrieve all the relevant data, like the group ID, the member ID, the insurance company name, and so on. And once we have that, then again, we can open up a web browser, go to the health insurance company's portal, and make a request and say, is this insurance coverage active? So those are a couple flavors of the types of automations that we do. And you can see that they're intertwined. So information extraction is useful, but it's more useful when you can also do the workflow automation of both reading the data as well as navigating to the health insurance company's website and making a request to them. So I just wanted to give you a flavor of what are some of the things that AKASA does so that the rest of the talk has some motivation behind it. Another thing that AKASA does that's actually pretty cool from the software side is called the expert in the loop model. So if you've heard of human in the loop machine learning, this is similar. So AKASA specializes in specific verticals. Currently, the one we're working on is called revenue cycle management. This lets us have basically an ops team made up of human experts who used to work on hospital billing teams. And these experts can train the bots during the initial build out. And they can do that by actually doing the task manually, but doing it in sort of an augmented browser that allows the bot to watch and learn all of the things they're doing, including where they're clicking, where they're moving their mouse, and so on. And then during regular production, so during runtime, if the bot has low confidence, then in real time, with very low latency, with low latency, we're able to send the task to a human to review it and correct it before finalizing. And this actually is a big motivation for why we started looking into workflow engines, because we realized that we had these very rapid tasks that a bot can do, and sometimes those get interspersed with higher latency tasks. Like, even if our humans are right on top of it, they're always going to be slower than a bot. And it doesn't make a lot of sense for the bot to just sit there for 5 minutes while the human reviews the work. Instead, it'd be better if the bot can do that in a non-blocking way and get other work done during that time. And that's part of what I'm going to talk about here. So here's the problem statement. And sorry, there's more text than I thought. But basically, we want a single Python script that can orchestrate our entire workflow. We have standard building blocks that we've turned into APIs. And I'll give you some examples. These building blocks are these automation tools I've told you about. Like, you might have a building block that says, go open up the EHR and navigate to a patient record. You might have a building block that says, open up a web browser and submit a request in the health insurance company's website. And each of these we've turned into functions that are exposed over an API. But every customer has different needs. And we want to be able to combine all of these functions in different ways based on the customer's workflow. And some of these API calls are fast, and some of them are very slow. Like, for example, if we want to go like update, months worth of patient notes, for example, that data entry may take several minutes. And it's really inefficient if our Python program just sits there and blocks on all of these API calls. Additionally, we have multi-stage automation. So we're not just calling one API, but we're often chaining them together to actually satisfy an end-to-end customer need. And if an automation fails partway through the workflow, we don't want to restart it from the beginning and redo all of the work that we'd already done, because that's very inefficient. But not only is it inefficient, but it's also dangerous, because AKASA in our business, we're logging into customer systems and we're mutating data in an external system. So that's not something that you can always safely repeat. So our problem statement here is, how do we get concurrency, retries, and resuming while still preserving the expressive syntax of Python that we all know and love here? And part of this talk is going to be an audit of open source workflow engines in the Python community. And one thing that I think we were adamant about internally is that we wanted to be able to fully use Python and didn't want to lose features that we love, like control flow or higher order functions, or didn't want to have to make things complicated just to write an if statement. And that's a lot of the motivation for this talk. Okay, so here are our requirements. We need a workflow syntax that's easy to write and maintain. Some companies, I think when I looked at a lot of the workflow engines built by some of the big companies out there, they're very tuned towards a small number of workflows that have to run at massive scale. When you have that, those requirements, it's actually okay to make the code difficult to write and maintain, because there's going to be a relatively small amount of code, and it's actually execution efficiency that's important. For us, every hospital in America uses software differently and has different workflows. And AKASA might end up with thousands of workflows in a couple years. And that means it's really important for the code to be easy to maintain. We also wanted the full expressiveness of Python. Like I mentioned, including control flow and higher order functions. The reason for this is that our workflows are very, very dynamic. So a lot of workflow engines out there are based on this concept of constructing a DAG and then having a very efficient scheduler to go execute that DAG. But with the AKASA workflows, sometimes we don't even know what we want to do till we get partway through the workflow. So,
What's a DAG?
Oh, a directed acyclic graph. So the way a lot of workflow engines work is you have a parent task and it spawns children, and that can repeat recursively. So you get a structure that looks like one node at the top, which is the function you call to start the workflow, and then it bubbles down to create a bunch more dependent tasks. And then a workflow engine will often provide a scheduler that helps you execute that. Does that make sense?
And the DAG is the scheduler?
Oh, DAG is just a concept in graph theory for that graph. So if you, so it's a graph that it has no cycles, which means that, like, let's say there's nodes A, B, and C. A can go to B and B can go to C, but then C cannot go back to A because that would be a cycle. So DAG is just a concept in graph theory and computer science for a graph that has no cycles and is directed. Which
None of them went
means,
back in time to become their own grandpas.
exactly.
Don't do that.
Cool. Heard. Excellent. Thank you.
Yep, no problem. Good question. Any other questions? By the way, I can't see the Zoom chat very well in my current setup, so please interrupt me. Cool. Yeah, so AKASA workflows are super dynamic. So for example, sometimes we will say, go through a list of insurance cards that we find in the EHR system. Scrape the image of the insurance card, run OCR on it, optical character recognition, to get the structured insurance data out, and then check the health insurance website for this health insurance company and see if this insurance is active. And then based on the one that you find is still the active insurance, you might need to go do something totally different if it's United Healthcare versus if it's Blue Cross. And this is an example of a really dynamic workflow because we actually have to inspect intermediate results to even decide what to do next. And this is one of the reasons why we don't want to hinder ourselves or get rid of a lot of the expressiveness of Python. And then obviously, like I mentioned, we wanted retries and resuming. We want concurrency. So we want multiple tasks to be able to execute at the same time. And ideally, we'd like to also tell the engine to prioritize certain task types over others. So I'm going to take a sidebar for a second, and this will all tie back in. But as we were going through our workflow engine design, we realized that a lot of it could be made easier if we made assumptions about how we write our APIs internally. So I want to take I guess a launch into the section about idempotent APIs. But before I jump into that, just wanted to see if there are any questions.
What does idempotent mean?
Yes, good question. That will be my next slide.
If anyone didn't get it, EHR means electronic health record. It's become very important in America and the world around, thanks to HIPAA. It's like Health Information Privacy and Accountability Act. It means, well, first, no, Health Insurance Privacy and Accountability Act. At first, it meant like if you came into a new health insurance and you had some pre-existing condition, and that's probably the key phrase you've heard in the political world, it meant that they couldn't say, oh, I won't insure you. But then it also meant if you're coming from one insurer to another, that they could port your record over. And it's made for a very, I think, an important leap forward in the world of information around the medical science world, because, well, I think AI should be applied there probably earlier than any other place. And so when it comes to, I don't know, machine learning aided, what is it?
Meliora.
Yeah, exactly. Dylan and I were on a Microsoft, what was it, Imagine Cup something? We did something with the Boston University machine learning thing where they were doing some stuff with, like, I don't know, deposits on Alzheimer's and like MRI scans. I don't know, it was heady. When was that? Was it in the spring or something? In any case, basically, EHR is very important to all of us. HIPAA is super important as well. And if you guys don't recognize this, basically, these guys are taking what we do with data science and like applying it to making sure that we're paying the right amount. You hear about people paying way too much for very simple things. And
Yeah, thank you, Woody, for that. That's great context. And sometimes I forget to go over that because I've been spending my whole career in healthcare, but I appreciate all of that context. And yeah, I should mention, they say that the #1 cause of bankruptcy in the United States is unexpected medical bills. And that's a big problem that we're trying to solve, but because most of the time those are due to billing errors or miscommunications. And that's something where we're trying to go in and prevent these errors before they happen so they don't bubble down to patients.
yeah, and this is just errors. This isn't, ethical pricing problems, but it gets to that eventually. Like that
I would
becomes
call bankrupting billing errors pretty ethically shady,
here.
personally.
All right.
Any other questions at this point?
Do you need permission to scrape the electronic health record?
Yep. And we have all of that, and we also conform to the highest standards of security. So one of our biggest engineering teams is infrastructure and security to make sure that we are making responsible use and also the smallest use possible of the data that we're collecting, meaning we're only doing it on a need-to-know basis. Okay. So this word idempotency is a big word. So wanted to go over that first. It's actually a simple concept. Idempotency, or an operation, is idempotent if it can be applied multiple times without changing the result beyond the first time that you did it. So here's a simple example from math. Multiplying by 0. You can multiply by something by 0 once. It'll be 0. After that, you can keep multiplying it by 0 as many times as you want. It'll still be 0. Here's some examples from computer science, from HTTP. Get request. You can get the same data over and over. And obviously, assuming no one else has changed it in the meantime, your get request is idempotent, which means you can keep applying it and you'll get the same thing back, assuming like consistent state in the world otherwise. Same with put. So if you want to update the property of an object, you can do that as many times as you want. You'll just keep overriding it to the same value. And same with delete. You know, it's not going to hurt to call delete twice on the same ID. But post, for example, is not idempotent.
I have a question.
Mhm.
Aren't these, I think they're called CRUD operations, right?
Yep.
Yeah. So
yeah,
certain CRUD operations are idempotent.
No, not all of them. So CRUD is create, read, update, delete. So get is read, put is update, and delete is delete. But create is not idempotent. So create would be the equivalent of a post request. And if you submit the same post request to a REST API twice, you'll create 2 records. Does that make sense? So it's like the RUD in CRUD. Those 3 operations are idempotent, but create is not. So idempotency can also be applied to functions. You know, I just gave you some examples of simple functions that are idempotent, but you can think about any function you could build being idempotent. Maybe multiply by 1, or another thing. Yeah, basically you can think of writing functions in an idempotent way. And this is important for AKASA because our automations mutate state in someone else's system, like an EHR. And our workflows can fail midway through their process due to issues that are not even our fault. Again, we're usually VPNing into a customer system. If their VPN goes down partway through our bot running, we don't have a choice. Our bot has to stop. But when the workflow boots up again, when the network is back up and retries, we don't want to repeat mutations that we've already done. For example, if we've already submitted an appeal to the insurance company, or if we've already paid the insurance company back for an extra payment or something, we don't want to do that again. And that's why we need idempotent APIs to give us, and this is an important concept, it's called at most once semantics. That means we want to be guaranteed that certain functions will run 0 times or 1 time, but never more than that.
You guys must have some serious logging.
Yes, absolutely. And also I think good API design, which we'll talk about. But yeah, good point. Any other questions there? Cool. So I think a company that does this really well is Amazon Web Services. Amazon Web Services published this blog post, which is short. It's only a couple of pages. It's called Making Retries Safe with Idempotent APIs. But it taught me a lot. And I recommend offline that you take some time to read this blog post if you're interested, because they'll do a better job of covering this content than I can. In the blog post, they talk about creating an EC2 instance. If you're not an AWS user, an EC2 instance is basically a virtual machine in the cloud that you can spin up. So it's a computer that you can rent from them in the cloud. And creating an EC2 instance, to someone like us, they've made it seem so easy. But under the hood, it requires several API calls within AWS. You have to create the VM, you have to create the block store volume, you have to create the network interface, and so on. And each of these API calls has some failure percentage associated with it. And the question for AWS is, how do you end up with exactly one EC2 instance at the end? So you don't want to end up with a VM and a block store volume that are floating around with no network interface tied to them. You also don't want to end up with 2 copies of everything if the client resubmits the request because they didn't get a response back the first time. So that's the core question. Let's say the client, I go submit a request to get an EC2 instance, and then my internet dies. So I didn't see what happened. So I'm going to go in and resubmit that request. And hopefully AWS isn't going to make 2 EC2 instances for me. So they talk about 2 ways of achieving this, this concept of idempotency so that retries can be safe. Again, the idea of idempotency here is it's a function that you can call repeatedly, but it makes no difference after the first execution. So I can call this submit or make EC2 instance over and over safely, knowing that I'm only going to get 1 back. And they talk about
How do you, what's dedupes? What does that mean?
Oh yeah, so it stands for deduplicate. So the first idea they propose is that the server, so AWS's servers, hash the parameters that I've passed in, and they apply some hash function. And so they say that if let's say the parameters are the command I want to run, like create an EC2 instance, as well as some configuration values, like what instance type, maybe it's a T2 large, how big of a volume I want, maybe 100 gigs, and some other parameters like that. So they would apply a hash function to all of those parameters that you pass in. And if they find that and maybe they're also hashing the caller's name. So they'll hash my name as one of the parameters. And if they apply that hash function and it comes up with a hash key that they've already seen, then they say, we've already seen this request, so we're not going to fulfill it again. Does that make sense?
Yeah, hash functions do that by like nature, right? Don't they? Hashes would can only take something unique. You know what I mean? Like they all have to be unique in some way. Or maybe I'm wrong.
Yeah, exactly. So it's a hash function where, how do you say it? If you pass it the same input, you'll get the same output, but no 2 inputs should collide and no 2 distinct inputs should collide and result in the same output key. Does that make sense?
Yeah, definitely. Thank you.
Yep. So that's the first idea that they propose. And then they quickly reject that idea because they say that what if I actually want 2 EC2 instances that are identical? And maybe I want them at the same time. It would be awfully weird for AWS to decide that I can only have 1 if I want 2 of them or 3 of them or 5 of them. And so instead, AWS opts for this second approach, which is called the client token approach. Here's what's happening. And by the way, for all of you who are wondering, like, I've made an EC2 instance, but I've never had to do this. The reason is they've built nice SDKs or libraries like Boto 3 that handle all of this under the hood for you. But the client, which is you, when you're submitting your request, you also submit a unique token. This is like a UUID or something similar that identifies your request. And then let's say your internet goes down, or maybe you don't get a response back from AWS and you don't know what happened. Now you can just resubmit the same exact request, but you pass it the same client token. That's this UUID that you generated on the client side to say this is a unique identifier of this specific request. And you can just resubmit that as many times as you want. And after the EC2 instance is made the first time, anytime you resubmit that request that says create EC2 instance and you pass it this client token, it'll recognize that it's already done that and it'll just return the instance ID for you. This is actually how AWS has implemented this. And if you want a second EC2 instance, that's fine. you just submit a new request with a different client token. That's all you have to do. And this is a really clever approach. It seems simple, but it has a lot of, I think, really pretty implications to it. And it's a really clever approach that gives the client flexibility. You know, in idea one, the client gets one EC2 instance, whether they want more or not. And in idea two, the client has all the flexibility that they want. And it's all based on this unique token that identifies the request. And this is kind of the idea that we use at AKASA. So one of the realizations we had is that if you have idempotent APIs, so by the way, this is an idempotent API now. So create EC2 instance is now idempotent, meaning you can submit it as many times as you want. And as long as you pass the same client token, you're only going to get one EC2 instance back.
That's actually interesting. It kind of could be thought of as kind of like a Boolean flag of sorts, where whenever you've submitted your first request, they now have a kind of Boolean flag of request exists.
Exactly.
And if request exists, then do nothing anymore.
Exactly. And Stripe also follows this pattern. And they have something that I think is really cool, which is on that second request or third request, where internally the server is doing nothing. If that's what happened, the server also returns a header in the response that says idempotent replayed true. So in Stripe's API, the server actually tells you that that's what happened. And Amazon's, I don't think it does. Good point. So that's an idempotent API. And what we realized is that idempotent APIs lead to replayable workflows. I'm going to explain what that sentence means. So at AKASA, all of our internal APIs follow this client token pattern that I just told you about. So that means if the client resubmits the same request with the same, oh, do my slides look a little messed up to you?
You sure do.
Yeah, there's like some coverage there.
Yeah.
Oh, now we can read it. Oh,
Yeah, let's try that again. How about now?
The artifacts are gone.
Yep.
Nice, cool. That was weird. So if a client resubmits the same request with the same token within some reasonable amount of time, then the response is returned immediately from the cache. And this is at most once semantics. Again, you'll get at most one EC2 instance in that Amazon example. You'll never get two, as long as you're using the same client token. So now let's pop back into the AKASA world. Oh my gosh, sorry. Okay, so if a workflow—
Is at most once similar to nonce? I guess I'm asking a question about nonce there. I don't know what that means.
Oh, you know, is that where that comes from? Because by the way, Woody
Maybe
brings up a
someone
good
knows.
point. Client token is kind of the new hip word for what has been called a nonce for 30 years or so. So that same idea of passing a UUID in with your request is also called a nonce. I don't know if that's where that word came from. That would be interesting.
Yeah, like hot once.
That would kind of make sense.
Oh, not used more than once. There we go.
Yeah, maybe.
Yeah. Oh, there we go. Awesome. Thanks, Sason.
Oh, that's actually what it is? Cool. So if a workflow fails midway through a series of API calls, so let's say there's 10 API calls that our workflow is trying to make, and it fails after number 5. Now it can just restart from the beginning and fire off all of the API calls again, starting at number 1. And the really pretty part about this is that if the call has already been made, then the server is going to have that client token on hand and will instantly return the response from the cache. And then, so that'll be for steps 1 through 5. And then once you get to step 6, that's the part that failed, so that work hadn't been done yet. Then you submit that to the server, it checks the client token, says, I haven't done this work yet, so now I'm going to start doing work again. So this creates, in the workflow engine space, it's called replay. This creates replayable workflows that allow you to resume where the workflow left off. But you didn't have to keep track of that state. You didn't have to log to your database like, hey, I started step 5, and then you see a failure, and then you have to check your logs and see where you failed and try to resume after that. You don't have to think about any of that stuff in this world. You just start at the beginning of your workflow. You just fire off all the API calls again, and everything that you'd already done returns instantaneously due to this client token pattern. So it's really, really powerful. And that's how all of our APIs work. So now that I went over that, I think you can see how this is going to tie in. Basically, we're going to use this pattern to get replay. And so the remaining question was, now that we know how to design our APIs, which workflow engine do we want to pick to actually execute the jobs? So that will take me into the last portion of the talk, where I'll do an audit of all the workflow engines that we looked at over a pretty detailed period of research. But happy to pause if there are any questions.
I have a bit of a random thought. From what you've described with this idempotent approach to generating APIs and doing work, and I apologize if this comes off as an inappropriate question, as I'm not actually a programmer. I just do compliance with Python on the side.
Sure.
But given my limited experience with it, it almost sounds a bit like what you're trying to do with an idempotent API could also be construed as a kind of thing that you do in that Haskell functional language, where you either do your work or you return none if the work isn't needed. Is that kind of similar to the approach?
Yeah, so I will say, first of all, as a disclaimer, I've probably written 10 lines of Haskell in my life. So
you only do it for shiggles. That's the main rule of Haskell.
So I don't know that I am qualified to comment on how Haskell does things, but from how you described it or how you presented it, that sounds like a good analogy to me.
And part of what you do is so you don't repeat yourself. That's pretty much is that correct, Nancy?
Sorry, could you repeat that?
It's basically a lot of what you do is so you don't repeat yourself.
Exactly. Yes. Yes, that's exactly right. You want to be able to retry the request because that's just a very easy thing to do, but you don't want the work to be done twice. And that's sort of what this is all about.
Cool.
Any other questions right now? And by the way, Woody, how am I doing on time? Let me know how quickly you would like me to wrap things up, and I can adjust the pace accordingly.
Well, we talked about around an hour. It's 8:03 Pacific time, so you're just under an hour, starting at 10 minutes.
Cool.
But I have a question.
Yeah.
So EHRs, I know I can name two. There's the big one, Epic.
Yeah.
And then there's like the cool one in San Francisco, Practice Fusion.
Yeah. Okay.
Do you work with both of those? If not for either, why not? Also, what others?
Yeah, good question. Kate, if you're there, what are we allowed to say here?
Sorry, repeat the question one more time.
What EHRs do you work with?
Yeah.
Which, I'm sorry, say that you, I didn't hear it.
Oh, yeah. So EHRs, what electronic health records?
Oh, I think
guys work on?
we can we're tailored to work with them all. So like Epic, Cerner, we can implement our solution into whatever the hospital has.
Yeah.
Nice. Do you work with Practice Fusion?
Not today, because none of our customers are Practice Fusion customers. But the way our system is architected, we could easily work with any of those systems.
Nice. Well, maybe you guys could start to set it up so they can come to you.
Yeah, Good idea. Cool. Okay, I'm going to try to breeze through this portion. I think I talked about API design, which is what I was most interested in talking about. This part is about workflow engines in the ecosystem. And I'm going to skip over some of the text that I have. First category of things that we looked at is called a message broker. Message broker is actually not really a workflow engine, excuse me, but often gets lumped in with it. So message broker basically means that you can send messages to a queue and then have something read from that queue. There's a lot of solutions that exist. There's a PQ, which is just a Postgres-based queue. There's RabbitMQ, Kafka, Amazon's SQS, and so on. The thing with message brokers is there's no return value. Oh, sorry if you're hearing sirens. I live on a very loud street in San Francisco. There's no return value. So basically, it's like you're sending a letter, but you don't get any guarantee that anyone's going to write back. PQ is a very simple Python solution. So it uses the Postgres database as the backend for a queue. And gives you a Python library that basically says pop an item off of the queue and acquire a lock on it while I do my work on it. We already use Postgres, so this was appealing. No additional infrastructure for us to manage, and had some good semantics. Yeah, including the semantic about transaction locking. So basically, you can lock a message while you work on it so that no other worker can go claim that message and cause a race condition. So message brokers are a good way to establish isolation between microservices. If you want two microservices to communicate with each other, one thought is they can have a REST API, and the API functions there can publish to some message or topic. But the one thing about message brokers is that their pattern is fire and forget. So again, there's no guarantee that anyone's going to write back, and that can cause some trickiness if you're trying to manage. Another option we looked at was called Procrastinate. So this is a Python library. It's open source. It's actually really, really cool. I recommend taking a look at it. And it takes the idea of a message broker to a higher level of abstraction. So instead of just sending off a message, usually that message would include JSON, and some data element within that JSON blob would indicate, what function you want the worker to run. In Procrastinate, you can actually schedule a function call. So you don't just dump some message in a database and hope someone picks it up. You can actually just say, run this function call at a certain time. So it kind of gives you a Python library with a cron-like syntax to be able to run Python functions from Python, which is kind of cool. Not something I had really seen before, and seemed very appealing. Other than that, I'm going to skip through some details about it for the sake of time. I thought that it could be really concise, more concise than message brokers sometimes. Yeah, but probably biggest downside is they had this idea of transaction locking. So you can lock a function call while you're trying to work on it. But if the function call failed, the lock doesn't get released. That's kind of a bummer, which meant that sometimes jobs can just be left in this pending state for some infinite amount of time until you go clean them up, which is not great. It's probably fixable, but that's how it works right now. Okay, then we looked at Airflow and Prefect, which are some pretty popular workflow engines. Airflow, I believe, came from Airbnb and just now has spun out into its own open source thing. And Prefect is a up and coming company that builds the Prefect workflow engine. In both of these cases, we found that they weren't as dynamic as we liked them. So again, going back to that idea of the DAG, the directed acyclic graph, if you have a clear DAG that you want to run and you just need something to execute it really, really well, Airflow seemed like a great choice. Prefect seemed good too. But for AKASA workflows, where sometimes it's only halfway through the workflow that we decide what subgraph we even want to execute next, these weren't quite expressive enough for us. So we ruled these ones out. Then we looked at cadence and temporal, which are very fascinating. These, again, I'm showing you many flavors. Oops, I skipped a slide, but I'll come back to it. I'm showing you many flavors. I showed you the message brokers and PQ and SQS. Showed you probably a true workflow engine and Airflow. Cadence and temporal are often looped into this space, but they're actually sort of microservice orchestration frameworks. So that means you have a series of microservices and APIs that you want to call in sequence and run that very efficiently. So Cadence was developed in-house at Uber. They spun it out to become an open source repo called Temporal. Probably had all of the features we want, replay, resuming, all of that stuff, but they don't do Python right now. So they're primarily targeting Golang, which is used heavily at Uber. Also some Java, and I actually don't know if TypeScript is right or not. The other thing that was a little strange about it, not necessarily good or bad, but all the other things I talked about, procrastinate, PQ, etc., they give you like a Python library that you can pip install, and that's how you use the thing. With temporal, you actually have to run the temporal scheduler service thing on your cluster, and your application is basically submitting requests to it, and then it's telling you what to do. So it's a little heavy-handed on the infrastructure side because of that. It's not just a library you can install, but also some additional infrastructure that's sort of a black box that you have to run. But for us, it didn't really matter because we're a Python shop, so we need good Python support. Oh yeah, and then AWS step functions I was very, very intrigued by. So this is one of AWS's cool offerings. It basically lets you design a state machine visually using a drag and drop interface where you can drag and drop function calls and Lambda executions and things like that around. So it's sort of a low code type of thing. Looked super, super cool for simple state machines. But anytime you want to do something complex, or even not even that complex, like a for loop, we found that a for loop with an if-else statement takes a few lines of code in Python and turns into like over 50 lines of this JSON, which is what backs step functions. They also don't really have a good story on modifying existing pipelines, and you kind of have to make a copy of it, and it seemed like deploying and upgrading they didn't have a great story about. So so our conclusion there was basically state machines are not the best at representing complex control flow logic. So in summary, we decided to go with PQ, which is one of the message brokers I talked about, but add some tooling on top of it. So I told you that we didn't like the fire and forget model, which means you don't get a response back. So we added a results table on top of PQ, which allows you to query this table of all PQ tasks and see which ones are ready to be executed, which ones are currently being executed, which ones are done, and which are failed. That provides some more visibility into what work is being done, and we can use that to trigger alerts and analytics. We also built a REST API on top of PQ. So the idea here is that you call this API. The API server enqueues a PQ task, and then there's a pool of workers that can pull that task from the queue and work the task. And the good part about this is that allows us to use PQ even if we have some functions in other languages that aren't written in Python, because then they can just submit a post request to the API. And last one or two slides here. So here's the new flow. So by the way, we're almost wrapping up our build of the AKASA workflow engine and thinking about open sourcing it after that. So I'll keep folks posted on it. Here's the new flow. An engineer can write a top level function for their workflow. This function can call any of our APIs. But each of these APIs now, instead of directly executing the the function, it's going to enqueue a PQ task. So that's the first thing is enqueuing a PQ task is almost instantaneous as opposed to just like executing a long running function. So so the API basically returns immediately, and it just says I've submitted this PQ task. Here's an ID, you can check for it, and right now it's pending. So that's pretty cool. And then asynchronously, there's this whole pool of workers that is looking for open tasks, and it's going to claim a PQ task and actually run the function. This is the thing that can take a long time. But that's happening asynchronously because the client already got a response back that said, you know, I submitted a PQ task, here's the ID. And then when the worker is done, it writes its results to the database and marks the PQ task as done. Meanwhile, the client, again, the client got its response back immediately, and it can do other work during that time and then come back and poll this result on some specified frequency. And once the client polls and finds out that the API call was complete, then the workflow engine fires off the next API call. And that's basically the flow. So if the API call is still being performed, how our work, so if you try to pull for the results of a task and it's still in progress, our workflow engine will just fail that task and tell it to retry again a little bit later, which then unlocks it in the database. And going to the next slide, sorry, I'm just rushing a little bit here
I got a quick question for you. So this piece right here, is that, I think PQ, you said one of the things that it did was fire and forget. Was that the one that if something failed, it kept the record locked?
No, that was procrastinate. Good question.
Okay.
Yeah. So
I presume you have these learn how long each of your tasks takes, because if some are typically seconds, some are typically minutes, you don't want to interrupt the minutes one after 30 seconds and fail it, right? You'd want it to learn, oh no, it's nominally this range of time. Maybe here's a high water mark, and then you check it maybe a little bit of time after that or something like that. So you minimize your fails that shouldn't have been fails.
Yeah, and that's a great question. So actually, and I cover this on another slide, but the way we've done it to make that even more efficient is that now when a task, we still have polling, but we also have what's called notification. So when a task completes, it can actually notify its dependent task that, hey, I'm done. So you can resume
no lag
now.
there. You're not waiting.
Exactly.
Polling
so you can get extremely low
right
latency. Yeah, exactly what you're saying.
Excellent.
Yeah. And I think that's super slick because otherwise you could solve it by polling very frequently. And actually, I should have clarified, the polling doesn't disrupt the task that's in progress. Basically, when you poll, so what you do, and that's on this slide. So when you poll, there's no status endpoint. Again, this is the thing about idempotent APIs. You just resubmit the same request with the same client token. But this time, the API server, if it recognizes the client token, it's just going to look it up in the database. And it's either going to say it's done, and here are the results, or it's pending. So I'm just going to tell you it's pending. So it won't actually interrupt the execution of the worker that's working on the task. So you can poll as often as you want, and it won't interrupt the worker. It's just kind of inefficient and annoying to keep polling all the time. And so that's why this very last bullet point here is that for lower latency, we also implement this notification system so that when a task completes, it notifies the dependent task that it's now ready to resume.
Very good.
Does that answer your question?
Yes, absolutely. Makes a lot of sense.
Cool. Well, thank you all for bearing with me. Looks like I went a little bit over time, but I'm
No. You get credit for all the time that Woody talks, so you're actually under.
Yeah, absolutely.
Yeah, this is a lot of fun. And I also just wanted to mention we're hiring. You can contact careers@akasa.com, or here's our careers website, or you can email me anytime you want. I'm Sanjay@akasa.com. We're hiring backend engineers, infrastructure, machine learning, analytics, data scientists, product managers, everything you can think of. We are growing quickly and would love to work with you or your friends if you know anyone who's interested. So thanks again. And Woody, I am happy to turn it back to you.
Wait,
Thank
no,
you.
I got some questions on that one. All right, so AKASA, you guys are doing stuff with EHR. Could you do general things with CRM?
Good question. So I don't know a lot about that space. So you're talking about like RPA or like, yeah, can you explain a little bit more?
Well, you're talking about generalized workflows on, account management type tasks.
Yeah.
And so CRM is maybe client relationship management, that is like Salesforce, for example.
Yeah. This is one of the, I would say, downsides about spending your entire career in healthcare is I don't know a lot about that, and don't know that I'm the right person to answer it. I will say that everything I talked about in this talk on workflows can absolutely be applied outside of healthcare. You can imagine this whole framework we're building can be applied to any workflow you want to build that has a combination of quick tasks and very high latency tasks. That's really the general idea, is that if there's high latency tasks, you want your code to not block on that, and you want it to be able to go do something else productive during that time. So whether that's a ML training use case where you keep having humans label data, which is high latency, and then you retrain your model, and once it reaches a certain recall percentage, then you stop having the humans label, whatever it might be. Like, this is definitely a generalizable workflow solution. I just don't know a lot about CRM.
I mean, EHR is perhaps the most detailed account management possible, hopefully, because, medical science being what it is. I mean, client relationship management comes down to product specifics. It could be as simple as, insurance product. What's your coverage? How much do you want to pay? What's the type? Boom, done. Versus, everything that could go into, your 23andMe profile and what that means for your medical prognosis, whatever.
Right.
This is really cool. You said you guys are going to try to open source this? To some degree?
That is in discussion, and I hope we do. Yes.
I have a question about PQ. I was pointed to something Malte/PQ. It looks pretty old. Is there a newer version of it? Because it looks like the examples use Python too.
We use Python 3. I can follow up and get the exact pointer to the GitHub repo that we are using, and I will send it to you. I will say it's a pretty simple library. I know the one we're using is Python 3 compatible because we're on Python 3.8. But I do also believe that it's fairly old and generally pretty simple library, which is kind of what we were looking for, is something to enqueue tasks and then give us transaction locking and be simple enough that we could dig into the source code and extend it from there.
Is it mouth? So you're not exactly sure which one it is. PQ is a very hard term to search for on Google.
Yeah, I can imagine. I will find that even during this meetup, and I'll send it to you before we sign off.
Is that Python queuing, or is that a nod towards the classic statement, mind your P's and Q's?
I always thought it was Postgres queuing was what it stands
Postgres,
for. Yeah.
All the same. It's very
Try
detail-oriented.
PQ Python library, and I think it's the first one that pops up. It has a picture of an elephant on the page.
Yes, that's the one.
There we go. We found it.
Yeah, but it had the print statement. That may be worry. The old Python 2 style print statement in there as an example. So sounds kind of party foul-ish.
Yeah, it's possible they haven't updated their examples, but I know the code itself is Python 3 compatible.
Okay.
And I know the code still works, which is good.
I'd like to ask a quick question about the workflow development portion of what your company is doing.
Mhm.
So for that, am I understanding correctly, it's replicating the GUI interface with the end user, like essentially replicating the click events on places on screen?
So, okay. So I think you're asking about the part where we said that the humans can do the work at the beginning and the bot can learn from it. Is that right?
I think so, yeah. Essentially finding out where the humans clicked on things to access different portions of the health record.
Yeah. Yeah. So basically, we have some proprietary software to do that, which does log some of those things you mentioned, like keyboard actions and mouse actions, and lets us start auto generating code from what the human did.
Okay. And the underlying reason why that's long-term effective would be, and this is more of a business question case, like business longevity question, is that it's essentially kind of assumed the electronic health record system isn't going to really have major changes in the infrastructure of how you click through things.
Typically, they are fairly static. That said, most hospitals go through an upgrade cycle, which is usually 1 to 2 upgrades per year. And at that time, we can retrain our bots. But the good thing is, again, that our bots are all being trained with machine learning. So it's not like we have to rewrite all the code. Usually it just means we have to label a bit more data on the new interface, and then the existing code will still work. So it's just the machine learning algorithm that helps the bot detect the relevant entities on the screen has to be updated with new training data, but the code doesn't really have to change.
Because you're essentially at that point, is going to go a little mathy. You basically just could kind of almost like think of the screen as just some sort of projection, some sort of finite projection of the 2D plane, and going, that portion's really important. We don't really care about that portion over there. They close the screen, don't care about that. That kind of.
Yeah, something like that. Yeah.
Mm-hmm. Okay, interesting. Thank you. This has been a very interesting talk, by the way. Thank you.
Thank you for coming.
How long does it typically take from like an upgrade cycle and you have to retrain your algorithms? How long does that take, and does it change significantly if it's a less common workflow that they're going through?
Yep, good question. So I think this is where our machine learning based platform really kicks in and really pays dividends. Is that, as I mentioned, in most of these upgrade cycles, we don't really have to change the code. Or the way to think about it is, as long as the same information is still on the same screen, but just the orientation or the colors or the layout of the screen changed, if that's all that happened, then we don't really have to change our code, because all of the part about information extraction or information and entity recognition is in some machine learning algorithm, and takes us maybe a day to label some extra data, and then another day or two to retrain the algorithm, and which is very quick. We had a great success story with the customer who sort of did an accidental upgrade, and we were back up and running in 4 hours compared to other vendors, possibly taking days or weeks to get that amount of work running, because how a lot of other people do this is their code is hard coding in pixel coordinates of what you want to click on or something like that, which is then very, very inefficient. And anytime things change, you have to rewrite all of the code.
When you say labeling data, do you mean the expert users working on those augmented interfaces, or do you mean like you're looking at pictures of interfaces and labeling that?
Yeah, a bit of both.
Okay, cool.
Have you guys looked at any other general data formats for management other than EHR? Has it been all EHR?
All EHR on my side, but what I lead is sort of production and back-end software engineering, which means that where my teams are working is where we have signed contracts and are trying to deliver work. I do know we have people in the company looking at other applications of our technology and other industries being very excited about how AKASA could help out there. But I think we have a lot to grow and a lot to tackle just in healthcare first, and staying pretty focused there right now.
Do you find that clients running the same EHR system typically customize them so that you can't leverage the fact that version 5.03 of Epic at one location, if they upgrade to 5.07, that you've already done a 507 Epic somewhere else, you can kind of leverage that, or no, it's pretty much everybody, it's custom all the way through?
Really excellent question. We do find that there are some synergies there, and potentially at minimum, we know how to use the system, and we know, for example, which one of our computer vision algorithms tends to perform very effectively on that interface. And we're also looking more and more into whether, how reusable the code is. Typically, every client is doing different customizations, whether it's at the permissions level, or you can buy extensions to your EHR. So even if you have the same base platform, you can have different add-ons. But really good question. We're thinking about that as well.
I think it's fascinating, and definitely, there have to be. I mean, it makes sense. You don't want to rush away from your core, right? You want to, and as you say, you've got a huge market potential still just in medical. But I gotta believe, you've got some real opportunities in a number of labor-intensive areas.
Yeah, absolutely. We are super excited about it, and as I mentioned, we're only a couple years old, and our customers already do $100 billion a year in revenue. And they typically say that what's called cost to collect in healthcare, which means all the costs you have to pay to deal with health insurance companies, is about 3% of total revenue, which is a lot. I mean, you can do the math from there.
Right.
Do you have are y'all big enough to have like a dedicated hiring manager yet? Do you deal with new candidates? How does that all look?
Yeah, I do for my team. We have a recruiting team that can help figure out which engineering team people would be the best fit for, and then I'm the hiring manager for several of our roles. Yeah.
Is your like machine learning and engineering, are they like siloed at all? Some places seem to be pretty separate, or it sounds like you're mainlining your machine learning.
Very, very collaborative. My teams work with the machine learning teams every day, because that's kind of the core of the company is productionizing machine learning to make normal software better.
Cool.
Yeah, if you're interested in anything, feel free to shoot me a note.
I'll probably be shooting you an email in the next few days here.
Awesome.
Caleb, I
Thanks.
sent you the link to the AKASA careers page.
Thanks,
on
Woody.
Discord.
Yeah, just feel free to send it to me, and then I can just make sure at least someone follows up and talks to you.
I like being talked to.
Now, you guys are capturing a whole bunch of interesting data. I understand most of it won't be accessible directly by you guys, but you can make tools for it. If you're collecting EHR data, I guess it's mostly finance oriented, but if you're doing computer vision stuff, it stands to reason you could start applying that to some of their image files. And there's a lot of very interesting imaging in medical science. MRIs, for example, you're starting to look at like almost like volume files.
Totally.
Have you looked at that at all?
No, not yet.
Yeah, I mean the talk, just to remind everyone, not that I'm like grilling Sanjay here, but like it was about financial it's basically just like misbilling, and it's just this huge problem. But it just seems like you guys you're opening the door to a whole bunch of very like interesting analysis of what the hell is going on in medical science. I don't know if that, yeah, that's why I brought it up.
Yeah, absolutely. And all the stuff you mentioned is I have a lot of interest there. I come from working on the clinical side of healthcare and DNA sequencing and genetic testing and that type of stuff before AKASA. And I definitely know that the stuff we work on can be applied to the clinical side of healthcare as well, just like you're mentioning. And I think it's just a matter of when. Again, because we're a startup with a lot of ground to cover in front of us, and just deciding where to focus right now.
No, absolutely. Yeah, I mean, like you see the occasional thing on social media saying like, here's how much an inhaler costs in a different country.
Yeah.
You're like, what the hell? It's crazy.
They do have to maintain focus, because it would be easy to just splinter off in 10 different directions. And whatever you do, you want to do very well. And it sounds like this segment you are doing very well.
Yeah.
So you want to.
It's amazing.
Great. Again, thank you very much for your time. Appreciate it, and forward to following up. Take care.
Thank you.
All right. Well, anyone else got anything for Sanjay?
Thank you. Appreciate your time.
For real.
Yes, thank you so much.
Great presentation.
All right. Thank you so much for having me. I hope to be back sometime, even just as an attendee, to watch someone else speak. And Woody, let me know when the next one is, and I'll try to come by.
Oh, absolutely. Well, I'm.
Oh, Woody, I think you muted yourself.
Oh my, yeah. Well, thanks again, everyone. I jumped on the wrong presentation there. Sanjay, this was amazing. It's awesome to see what you guys are doing in the EHR space. Can't wait to see what happens. Also, I might need to back channel you on Kafka and general message brokers and stuff. Apparently, that's what I'm supposed to do for the next thing.
Sure.
Yeah. All right. Well, thanks again. If anyone else has anything for Sanjay, speak now or forever hold your peace.
Or at least until next session.
I guess I have a kind of like, I feel like this question might have a bunch of answers, but I'm just wondering like what kind of machine learning algorithms y'all are running. Like it sounds like, are you just like, there's some machine vision stuff? Are you doing like clustering on it? Like this is maybe a little gut stuff, but how are you approaching the layers here? Because is it all just vision?
No, a lot of different things. And it's a great question. I think what I would like to do is defer that answer to our machine learning team, who will be able to do a better job of telling you about all the guts there than I will be able to.
Sweet.
Where, yeah, and since
Line them up for a future talk.
Yeah, yeah. Actually, I'm sure they would love to give a talk out here at some point as well. So if folks are interested in that, we can get someone out here and have that happen.
All right, John, could you help us with that?
Yeah, absolutely. If you guys are interested, we'd love to pursue it.
Definitely.
Yeah, we'll make a note of it. Seriously, we appreciate the curiosity and on your end, and do whatever we can to make it happen.
This has been awesome. Just to remind everyone, John got us set up with Sanjay tonight, and Sanjay, you killed it. This is awesome.
Thanks again. Hope you all have a good night.
Thank you, Sanjay.
All right.